สวัสดีค่ะสวัสดีผู้เข้าร่วมประชุมทุกท่านนะคะก็ทันธิดาวงประสงค์นะคะอยู่ที่กองทุนความเสริมภาคทางการศึกษาหรือว่ากสศนะคะในวันนี้นะคะก็ต้องขอบพระคุณนะคะเครือข่ายของกสศนะคะที่ได้เข้ามาร่วมวันนี้หลายหน่วยงานทีเดียวนะคะโดยเฉพาะเป็นเครือข่ายผู้บริหารนะคะแล้วก็คุณครูอาจารย์จากโครงการทุนนวัตกรรมสายอาชีพชั้นสูงนะคะที่ร่วมงานกันด้วยนะคะรวมถึงมีคุณหน้าคุณตากันหลายคนนะคะในวันนี้นะคะทั้งผู้บริหารแล้วก็คุณครูอาจารย์นะคะรวมไปถึงเครือข่ายอื่นๆนะคะที่แม้ว่าจะไม่ได้ร่วมงานกับกสโดยตรงนะคะแต่ว่าก็เป็นเครือข่ายที่ได้ทำงานด้วยกันนะคะไม่ว่าจะเป็นการร่วมเวทีต่างๆนะคะแล้วก็การปฏิรูปการศึกษาร่วมกันด้วยนะคะก็ต้องขอบพระคุณทุกท่านที่ให้ความสนใจนะคะก็เดี๋ยวขออนุญาตกล่าวทักทายเป็นภาษาไทยแค่นี้ก่อนนะคะเดี๋ยวอาจจะขออนุญาตได้พูดในเป็นภาษาอังกฤษนะคะเดี๋ยวมีล่ามแปลภาษาอยู่ด้วยนะคะเพื่อที่จะได้ให้ทางวิทยากรเนี่ยได้เข้าใจเนื้อหาในการคุยกันด้วยนะคะเมื่อกี้ทางผู้ดำเนินรายการคุณวรรณสนันท์ก็ได้แนะนำนะคะว่าถ้าจะแปลภาษาเครื่องมือแปลภาษาก็คืออยู่ตรงที่เป็นรูปโลกนะคะอาจารย์ทุกท่านถ้าถนัดภาษาไทยมากกว่าก็สามารถใช้เครื่องฟังแปลภาษาได้ด้วยนะคะก็ so once again so good afternoon everyone and good morning to our guest speakers as well. I would like to welcome you to the International Forum hosted by Thailand Equitable Education Fund. The forum has been conducted for 3 years with wide range of top topics that related to equitable education. We have speakers from India on neuroscience and children and development. And we also have speakers from South Korea on Meister School as well, and many more issues from China and New Zealand as well. And the forum actually aims to bring together experts, school principals, and teachers. And this forum aims to provide, to demonstrate actually the learning collaborative and developing of practical knowledge on equitable education. The topic today is on TVET. As many of us know, I think Thai government had launched what we call Thailand 4.0 and policy. This actually policy aimed to transform Thailand into an advanced economy by developing the new technological advanced industries. Although there has been an emphasis on train high-skilled graduates, but there needs to be more focus on supporting and training teachers in these high technology industries as well. And when people think of vocational education system, they often think of Germany model. And of course, I think it would be difficult to replicate Germany's model due to difference of context, but there's a lot that Thailand can be learned from Germany. And today, I think with a very great support and very kind support from GIZ, we are delighted to have Dr. Georg Spöttl, the director of the Center of Technology, Work and TVET at University of Bremen, and also director of Steinbeck Center Innovate with us. Dr. Georg is also the president of the TVET research community in Germany. His expertise is on vocational education science approach as well. We are very much looking forward to learn from you on that area as well. And so we also have another key speaker that later on we will be meeting with him as well. We have Associate Professor Dr. Krischonme Bhumkittipich, the Vice President from Rajamangala University of Technology, Thanyaburi. His expertise is in electrical engineering and research. So Rajamangala University of Technology, Thanyaburi has been working with EEF for the last 3 years as well on TVET. EEF has been working with about almost 100 TVET colleges across Thailand. And now we've been supporting in terms of curriculum, developing curriculum and teacher training, and also provide scholarship to the least, the most disadvantaged students to go to get scholarship to study in TVET as well. So we are very excited to have both of you. And I think without further ado, Dr. Georg, the floor is yours.
Good afternoon to everybody again. I have learned this morning already that a lot of the participants have a TVET background that makes it easier to understand and to talk about the topics I will bring in. I will talk on the one side to the future of the jobs because of the changing industry. In Thailand, you call this changing industry advanced industry. In many other countries of the world, we are talking of industry 4.0, or we are talking of digitalization. And this movement in industry, which is a very tough movement, will be one part of my presentation. And the second part of presentation will deal with a program to train teachers, which we have created with the help of the Southeast Asia countries. That means including Thailand, supported by GIZ. And this initiative for establishing this training program for teachers was monitored, was organized by the program which is called RECOTVET. So that's a little bit the background of what I'm talking about. The third area which I'm using for my talk is a research outcome we have in Central Europe in the meantime concerning industry 4.0. So please go to the next slide. When we are talking of industry, we are always using the term complex. That the industry is getting complexer, and for example, that it is more difficult for TVET people to come into this complexity. When we have discussed about complexity about 15, 16, 70 years ago, we always have had some mechanical issues in the focus. That means our focus was the mechanical machinery, which was getting complexer and complexer. And in this slide, you can see this idea of complexity with a very close link to a mechanical machinery. But what has changed over the last 60, 50, 70 years? And this I will make clear on the example of the car technology, because the car technology is a fast-moving technology where it's possible to explain the changes which will happen over the last 50 years. This is a diagram which demonstrates the pages which were necessary to repair a car, in this case, a General Motors car called Opel, with an average size, not the top level of the car, not the lowest level of car, the intermediate level of the car, of the technology which was used was in the center. So the message of this slide is that around 70 years ago, there were maximum 500 pages necessary to understand the car and to repair a car. That means the people in the workshops have got around 500 pages a year for repairing a car. When you look at this slide about 20 years ago, the mechanics have got already 14,000, 15,000 pages to repair a car. And when you ask the mechanic in the repair shop nowadays how many pages they will get every year via the diagnostic instrument, and the answer for an Audi will be that they get around 65,000 to 70,000 pages with information how to repair an Audi car. So this is a different complexity. And the reason of this complexity is that we have not only a mechanical car again, we have the combination of mechanic, of electronic networks, of software, which is monitoring the whole car. So we have much more technology and software combined in a car. So cars are an electronic network nowadays, and the mechanic plays still a role, but not an important role anymore. So the complexity is driven from many different technologies in this case. And the question is, do we still have a standard car mechanic to repair this car, or do we have engineers with an academic background in the car shops? When you look in the car repair shops, you will meet people with a TVET background. Usually you will not meet engineers. About 5 years ago, we have made a study in Germany under this question, and we have asked 4,000 car mechanics about their background, and all of them, with one exception, all of them have had a TVET background, not an academic background. There was only one person with an engineering background. The message of this situation is that it's possible to train the people in the TVET area in a way that they are fit to deal with this complexity. And when you look in a BMW, in a Mercedes, or in a Toyota, or whatever, you can feel about this complexity, and well-trained car mechanics are able to do also repair work, and they are able to deal with the 70,000 pages because they know very well what pages are really relevant. And finally, the circuit diagrams are the most relevant, and they know how to find these pages, etc., etc. And approximately the same movement as it was going on for the car to build up a car which includes electronic networks. The same movement is going on nowadays in the industry, and the overall term which is used is smart factories, or as I have mentioned already, we are talking from Industry 4.0, etc., etc. The direction of industry is moving very clearly in this direction, that the production in the manufacturing areas gets complexer and complexer because networks are introduced. All the activities which are relevant to produce an item are interconnected. And for this interconnection, also the internet is used to exchange status worldwide. And this is a very tough movement. All the global players are already implementing these systems, using these systems of interconnecting the different activities. A different situation we have when we look at smaller sized companies. They are not moving so fast. In many cases, they have the traditional way of production. And the big question is how to support them that they can move up to the level of the global players to stay alive in the future. So the question is, what are the consequences of this movement? In the meantime, we have some answers, and I will focus on answers with the TVET background, and I will answer this question: what are the consequences? What do we need in the future with a focus on TVET? Next slide, please. When you look at this slide, you can read a statement from Schwab. He's the leader of the World Economic Forum, which is running every year in Switzerland. And in 2016, he has brought in a quite interesting statement which says that all the way we live, work, and relate to another will change. When you look at the movement which is going on nowadays because of digitalization, because of Industry 4.0, because of the future orientation of the industry, we have to say his statement, Schwab's statement, is reality already. We can feel every day the changes which are going on. The digitalization is going to the fundamentals of our life. All what we are doing every day is finally influenced by what's written in the iPhone. And nowadays you see people running around, they always have the iPhone in their hand, looking at the iPhone, asking the iPhone a lot of questions, and the iPhone answers it. So this impact of this latest movement of digitalization, the use of networks interconnected with the internet, this is a reality already. And these networks and these interconnections are also used in the industry in the meantime. So the question is, the next slide, please. What is the impact of this to the work? How does work change? And next slide. And here only a few statements. We could discuss a lot of things, how work is changing in the industry. But the main movement is that with the use of the interconnection, with the use of the platform, with the use of the networks. The production systems are much more flexible as in the past. The cycles are shorter. The production cycles are shorter. The delivery times are shorter. Also, working times are much more flexible as in the past. The tasks are much more flexible. That means people have to fill different tasks in the meantime, or a number of high tasks in the meantime. Yesterday, I have read a very new study in Germany, and the researchers have talked that for a normal worker in Germany, in the production areas, about 3 million new tasks will be available. I don't trust this statement, but it's a signal that things are really changing, that also the tasks, and that means the requirements for TVET people are changing a lot in the meantime. What else is new? New is that the cooperation in the industry is much more important as in the past. The cooperation between the workers, the cooperation between workers and academic people. And a very fast-moving issue is the uses of mass data and the exchange of mass data all over the world from the global players. So they can use the optimized production data all over the world in the meantime with the help of the internet. So many things are changing in industry, and based on this, the next slide, please. And based on this, ILO has made a study in 2016, so it's 5 years old already, but there is no later study available to this question. ILO has made a study on the risk of automation. And the overall outcome of this study was that 60% of the salaried workers in Indonesia, Philippines, Thailand, and Vietnam are under risk. That means their workplaces are under risk. And the question is, what means risk in this case? Does it mean that around 60% of the workplaces will go, or that they will change? This is not made very clear in the study, but I would interpret the outcome in the way that 60% of the workplaces will change. Not all the workplaces will get lost, some will get lost. Change of work means that people have to be trained for the new tasks. And in this area, TVET is required to make the people at the shop floor level fit for the new tasks, for the tasks which are required of the latest movement in the industry. Next slide, which is going a little bit more deeper into the risk of automation. With this yellow background, you can see the risk for Thailand in some areas. And in this case, the wholesale area is mentioned. And when it comes to low risk, then the message is that 2.4 million people are under low risk in the wholesale area. And you can imagine that the whole wholesale area can be reorganized by using the networked computing systems and do all the bookkeeping, etc., automatically by the computer. And when this is happening, workplaces are under risk. And that means a lot of the workplaces are changing and new tasks are relevant and people have to be trained for this new task. For the food service sector in Thailand is mentioned in this slide that 624 people are under risk. That means their workplaces are not so safe. The minimum will be that the workplaces will change. So these figures are frightening a little bit, but we don't have to believe all of the studies that is really moving into this direction. And when we look 5 years later, when you look nowadays into the industry, we can see already that workplaces are changing, but almost no workplaces are really lost. So what is common sense in research? In research is common sense that especially the low-skilled jobs. The low-skilled peoples are under deep risk because the standardized work can be automized. And you are working in this area, so it's very important that you take the low-skilled people under focus and that you think what's the best ways to train them that they can update with the latest requirements of the industry. So this is common sense in the research. Or the other way around, always when it comes to routinized work, where the task always repeated, the expectation is that this task might be replaced by a computerized system. So in this area is a risk. That means, with other words, when you work as a teacher, when you work as a researcher, and when you work in these service areas, you are not under risk. But when you work in a manufacturing company, then there is always a number of workplaces which is under risk. But the other way around, when we look into the market of Germany, and we are just doing a study in Industry 4.0, there are no workplaces getting lost. The industry needs more workers nowadays as 5 years ago, but the people have to be trained in a different way. So this is the tough requirement we have. So here, the outcomes of Germany, and what's written here, where's the outcome in 2016, as we have made a study, and we have the same outcome in 2021 again. When it comes to better qualified people, that means well qualified in the TVET areas. In this case, we call them qualified skilled workers, or we call them master craftsmen, or we call them technicians, or we call them semi-engineers. That means that's all people which are qualified below the academic sector. And from this well-qualified people, the industry is asking for 20 to 30% new workers in the meantime. So for this qualified people, no workplaces are lost. They have better chances to get a workplace as 10 years ago. But the low qualified workers under high risk, because industry tries to automate the work in areas where routine work is in the center. Routine work can be replaced by computers. So semi-skilled people and unskilled people are really under risk, and we have to spend a lot of efforts to bring these people to a level of skilled workers. So for the German market and for many European countries, the outcome is employees with a higher vocational or engineering education background are highly welcome in the industry, which is driven by Industry 4.0 nowadays. So well-qualified TVET people have a very good chance for employment. What are the needs of the industry? The next slide, please. This is the area of the work we are doing, the area of research we are doing in Germany and in also tougher industrialized European countries. And I will bring in some outcomes to say very clearly what's the main requirements, because these main requirements of this movement underpin that TVET people are still needed in the future. So go to the next slide, to the example of robot operation. When you look at the left side of this slide, then you can see the main issues of new tasks, which are relevant, for example, when people operate with robots, but also when they are operating computerized machinery nowadays, the same requirements are relevant. One area is that mechatronics, that means the interconnection of different technologies, is highly relevant. It's not enough to train people on a simple mechanical machine anymore. People have to be trained on mechatronic machinery in mechatronic plants. They have to learn about software and the role of software, for example. And the other very important point is that everybody, even at the shop floor level, have to have a process understanding. That means they have to know how the product is running to the factory. It's not enough anymore that they do a simple job which takes 12 seconds. They have to be aware of the whole plant, of the whole machinery with which they are working, to understand if there is any fault, how to react. Another point which is very important, that's data. As I have mentioned already, a lot of data is in the meantime available, because in all the machineries are sensors which are collecting figures, and finally for the production, but also in the service work, data are available which people should use to optimize the production. That means even a skilled worker has to learn how to read this figure, how to interpret this figure, and what's the relevance of the different figures which are coming usually via a monitor to their workplace. When you visit industry nowadays, and it doesn't matter which one, when you visit, for example, a car production unit, you will see a lot of monitors where all these figures are available. And even TVET people have to understand these figures, and they have to follow these figures. Another area is the so-called parameterization. That means update of software and such things. 10 years ago, this was not a job for a person which was trained as an industrial mechanic. But nowadays, this is a standard job for a person which is trained as an industrial mechanic, to be able to apply new software, to do software updates, or to do some changes on the software. And another area which is very, very interesting when you look into the industry is the communication and the cooperation between the skilled workers and between the skilled workers and the engineers with academic background. This is very important nowadays, because they have to exchange their ideas. They have to exchange when there is a fault, about the reasons of this fault. And the barriers are that the skilled workers usually talking a different language compared to the people with an academic background. So to create this communication is not so easy. On the right side, you can see a real example. I will not explain this example now. What are the tasks for a person who is running a 6-axis robotic for welding? Important in this case is how the work is organized and which software is used to run this robot. So the requirement of the industry is that the workers, that the blue-collar workers are able to handle these robots. That means that the software to handle this robot has to be designed in a way that skilled workers can understand it and can operate it. And there are solutions in the meantime available which are called low-code programming. Low-code programming are very simple application-based programs which all the blue collars are able to learn, because it's not very difficult to learn this low-coding programming. You can meet this in companies. Companies don't want to send academics to operate a workplace, even if it is a workplace which works with robots. Academics are too expensive for the companies to work in these areas. So they still prefer TVET people in this area. And that means that the technology or the software has to be shaped in a way that people with a skilled background, with a TVET background, can make use of this software. I have met this requirement also in a visit we have done a few years ago in a Thai company somewhere in Bangkok. I don't know in which area. This was a medium-sized company, and in this case, for example, the owner has done or has prepared the programs in a way that the skilled workers were able to make use of it directly on the machine. And here in this slide is also mentioned the teamwork is very important, and that different categories of workers and engineers have to cooperate, which is quite a tough way to go because they are not used to do this and they are not trained to talk to each other. And in many companies, it needs training and it needs activity that these different groups are coming together to work on the same task. When it comes to the new companies, here is something like a summary. You know about this term 21st century skills. In this case, I have to say, with a German background, the 21st century skills are not so new anymore, because this discussion about similar skills as behind the 21st century skills, this discussion we have had in Germany in the 70s and the 80s of the last century, and we have used the term key qualifications at this time. So problem solving, creativity, cooperating, communication, this was all highly relevant already 20, 30 years ago in Germany, and it was introduced in the design of the curricula. That is the reason that I not come in with the 21st century skills here. I come in with the broad competences linked to the latest movement of industry, linked to Industry 4.0. So there is one important area nowadays which is really new. It was not relevant 5 years ago for TVET workers, for skilled workers. That means that they have to understand software and they have to start the work from the software side, because the machinery is interconnected with the help of the software, not with mechanical elements anymore. So this is, let's say, the toughest requirement to reorganize all the training in the directions that the software and the monitoring of the processes with the help of the software is in the center of the training. People have to understand the network structures. I have underpinned already that in the smart factory, in the Industry 4.0 factory, so all the machinery is interconnected via networks. So TVET workers, EVET TVET workers have to understand this network, because after the machinery starts to run, in the first few weeks, it's supported from engineers, but after a few weeks, blue-collar workers are responsible to run this machinery by their own, in many cases over 24 hours. And if they have a fault, they have to solve this fault, because on Sunday morning and the weekend, an engineer will not be available. So people have to be trained to understand these networks. And they have to be trained to deal with the status I have mentioned already. The next topics are dealing with the same aspects. Again, for example, that many different formats available of the data. This creates some problems. The understanding of the master process is very important. And finally, when it comes to the point that the blue-collar workers have to run the machinery, they have also to take over responsibility for this process. That means they have to be really deep into this process to understand everything. And they have underpinned already, they have to be cooperate, they have to be able to cooperate, they have to be able to communicate with different disciplines, with people with different backgrounds. And for example, in the German TVET system, it's very important to develop the innovative competence of the TVET people. That means TVET people should be in the position to come in with new ideas. They should be in the position to participate in the decision how the work should be organized to support a good production process and to support the quality. So this is a very important issue, and it can be made to a subject of training in the TVET system. If you ever have the chance to visit, let's say, a company in Germany which is doing a good training, then you will see that innovation competence plays an important role. Let's get to the next slide, to the 3 dimensions. When we talk of all this movement, most of the cases we are always focusing very much on the technology. But it's not enough to have the technology in the focus only. It's very important to have the work and the work organization in the focus as well, because we as a work organization, it's decided which type of quality is relevant for production systems. And the third dimension are the social implications. The social implications are very, very important. We have to discuss the consequences for the people, for the humans when it comes to the movement of these latest technologies, because we are confronted with this movement. And when it comes to this point, the question is also how blue-collar workers can participate in a shaping process which is positive for them, which ensures their workplace. And under this point, the question is how people have to be qualified. So this is a very, very important issue. And especially when it comes to teacher training, this issue has to play a role. And when it comes to the RECOTVET program, which I will explain in a few minutes, we have taken care of such requirements. We didn't focus only on technology. We have covered a number of areas around the technology as well. What to do to support this process of taking care of the human? In this slide, what you can see now are two scenarios are mentioned. One scenario we call the automation scenario, and the other scenario we call the expert scenario. To make it simple, the automation scenario is driven by the technology. So that means the technology dominates everything. And people have to fulfill the tasks which are required from the technology in a very simple way. And when it comes to mass production, this scenario is under tough discussion because everybody expects when everything is automated, then the production is very cheap, no humans necessary anymore, and it will run. But there is no company of the world which has 100% automation scenario up to now. The alternative scenario is a so-called expert scenario. The expert scenario means that also workers, also engineers, also people who are working in companies are qualified in a way that they are able to shape the work processes in a human-oriented way. When a skilled worker should have these competencies to participate in the shaping processes, then they have to be trained into this direction. And there are training concepts available which support this. We never will have a 100% perfect solution, but we can go a step forward into this direction to put the humans more into the center and to organize the work in a way that it takes care of the humans, of the behavior and interests of the human. So this is a very important area. And for example, when it comes to Germany, maybe you know that we have very tough trade unions in Germany, and the trade unions in Germany are supporting this expert scenario. They put the humans into the center. And in many cases, it is possible to organize workplaces in a way that humans have to have a place over there. So a little bit philosophic idea. When we want to support the expert scenario, then this means very simple. We have to design human-centered curricula. When we design curricula for the modern industry, we have to think how we can design it human-centered to give the expert scenario support. And we will not succeed when this is doing a single school, for example. And in Europe, this aspect is deeply under this discussion. And in Europe, a lot of so-called intelligent alliances in education and in TVET are established in the meantime. I don't know exact the figure, but a minimum of 40, 50 alliances are established all over the countries in Europe, where in projects people work together into the direction to support human-centered curricula. So this shows there are chances, there are opportunities to support this direction, even if we will not have a perfect, 100% perfect solution finally. But important is that we are going some steps into this direction. So this is about movement because of Industry 4.0. This is one way how to come to approaches, to solutions, to support workers, to support the TVET system to go into this direction and to prepare people for the latest requirements. And in the so-called RECOTVET program, we have designed 4 modules which are the backbone of the curriculum, how to qualify teachers for this latest industrial movement. I will explain only the main issues of this, how we have designed the curriculum. As we have designed the curriculum, we have done 2 areas. One area was that we studied also empirical studies which were available, and we have visited some enterprises to identify the most important requirements. And this visit was done with the help of experts, and we have had a lot of expert discussions. The experts were coming from the 10 Southeast Asia countries. There were quite a few colleagues from Thailand participating, supporting this process. And we have identified what are the latest requirements of industry. And based on this requirement, we have designed a curricula existing of 4 modules. And to support the implementation process of the curricula, for this we have designed so-called learn and work assignments. And I will show one example. Here you can see one title of one module. This was the module number 1. It's called Innovative Teaching and Learning for Industrial Changes Due to Industry 4.0. And below you can see, and this we have more detailed, all this material is open, via open access available, so you can get it. Under this we have designed for this module number 1, 4 learned work assignments. And for example, learned work assignment number 1, new paradigm, the changes of management and work processes and consequences for the workforce due to industry. So this was a learned work assignment to support an introduction in all these latest requirements. And already when it comes to learned work assignment number 2, you can see already that man-machine communication, optimization of automation and consequences for the workforce were in the center. So with the help of this learned work assignments, we established the teaching process, and in the teaching process is learned and work assignments were in the center, and the learned work assignments are connected to very concrete requirements, and these concrete requirements were the driver of all this training which we have brought in the training process, and which we have used for competence development. Model number 2 is dealing with the professional development of Industry 4.0. In model number 2, we went much deeper into the technology requirements and work requirements of the industry, and these technology areas were covered by, in the training process, were covered by TGI and in Bangkok and GMI in Kuala Lumpur. And we also have designed a module number 3 for curriculum development under the question how to develop a curricula under the requirements of Industry 4.0. And we have decided that we design work process related curriculum. And module number 4 was dealing with the quality. What quality has to produce in the training processes because of these requirements of Industry 4.0. I think I still have a few minutes, so I can explain the next slide a little bit. What type of training concept we are following? We were following the concept which was in first steps designed in the 80s from Dreyfus. Maybe some people have heard of this. They created a concept from the beginner to an expert. So under the question, how can a beginner become an expert? And for the beginner, the overall knowledge, the orientation knowledge, the overview knowledge is important. So when you look at module number one was a typical module which was dealing with the overview knowledge. So with the help of module number one, we have introduced the people in the general requirements of the movement of industry for thorough. Module number two is already dealing with the technical requirements, with the networks, etc. And the comprehensive knowledge will be or was developed under this aspect to create a comprehensive knowledge of the networks, how networks work, how data are used, etc., etc. And in module number, and even in this case, in module number two, we also went deeper into the function of the new machinery, of the platform-based machinery, of the network-driven machinery. So we went quite deep into the details of the plants, of the machinery. And finally, we came up with a very specialized knowledge, but only in some cases we didn't go so deep when it comes to this. And to drive along this movement from the beginners to the expert. The expert means they are really able to operate the whole machinery, they are able to identify the faults, they are able to repair the machinery, etc. With the help of the learned work assignments, where we have designed simpler learned work assignments for the orientation knowledge, then we went up to more open type of learned work assignment. That means more complex learned work assignments for development of the comprehensive knowledge, for the development of the functional knowledge. And finally, in some cases, we have had this so-called open innovative types of learned work assignments to support this specialized, the development of the specialized knowledge. So this was a concept which we following in very short. It was a long discussion in these expert groups, whether we should go along this or maybe some other approaches are available. But finally, we have pointed out that this is a most interesting way to go. And there is a documentation available, open access. You can get this document via the Samio Voctec network. There is a so-called quality toolbox available with a lot of hints for the methodic, for the didactic, which can help you to design your learning sessions. So also this document is available via the Samio Voctec network. So this is the end of my presentation. I hope I could give you a deeper insight into the requirements of this latest movement, Industry 4.0 or digitalization, or how do you call it in Thailand, advanced industry. And I hope I could also give some hints that there is a chance for training to come into these areas and to train people in a way that they are able to deal with this latest technological movement, to ensure that people have still workplaces for the future. And for TVET, we have really quite a lot of work and tough work in front of us to cover the requirements.
TVET delivery is high on the agenda of ASEAN member countries. TVET is expected to produce skilled workers needed by the labor market. At the operational level, teachers become the key actors to shape the quality. They run the core business of TVET from the workshops and classrooms. However, teachers are not always sufficiently included in the quality development process. As a response, RECOTVET has taken the initiative to develop a quality toolbox, aiming to equip TVET teachers and managers to emphasize quality more effectively and efficiently. Being developed with the involvement of TVET experts from the ASEAN member countries, the Quality Toolbox features 6 thematic areas. Thematic Area 1, Quality Culture at TVET Institutes. Area 1 addresses the basic components of a quality framework, such as vision, mission, and strategic plan. It also stresses the importance of team concept to foster quality culture. Thematic Area 2, Paradigm Shift in Learning and Teaching. Area 2 addresses the holistic focus on TVET delivery, covering input, process, output, and outcome. In this context, qualification standards, curricula, didactical approaches are the three components that are subject to continuous improvement with a strong linkage to industry requirements. Thematic Area 3, shaping quality indicators and standards for quality development. Area 3 highlights the approaches to set up a quality development framework. Users will get exposed to the steps and procedure to develop their own quality standard and indicators. Thematic Area 4, classroom instruction methods. Area 4 offers a step-by-step guidance and methodical advice to enable teachers to select adequate teaching approaches. A range of instructional methods, from lecturing up to self-reliant learning, are discussed in this area. Thematic Area 5, classroom assessment. Area 5 underlines various approaches to effectively assess the learning outputs. Users are guided to use different tools for both formative and summative assessments, such as classroom sit-in, rubric, checklist, and rating scales. Thematic Area 6, cooperation with industry. Area 6 helps to manage the cooperation with companies. Cooperation areas such as curricula development, joint delivery, and assessment of training are outlined. Practical examples provide a picture on a strategy to strengthen interlinkages of training and industry. With these 6 thematic areas, the toolbox is aimed at TVET practitioners in the ASEAN region to work towards better quality TVET delivery.
Yes, so that's the video presentation. Dr. Georg, would you like to say something on the video, please?
The video explains the key points of this training program, and the training program, and maybe this is important to mention, the training program itself we have implemented, and we have done the training, and we have trained around 130 multipliers from the different Asia countries. And this was the first turn, but we couldn't really start with the second turn of the training to continue to train multipliers because of the pandemic situation. Just in the moment we are in the process to reorganize this training and to offer it as a digitalized based training. The tough requirement, and all trainers know about this, the tough requirement is how to bring in the laboratory exercises into a digitalized training. But this process is going on at the moment, and the planning is that in March next year, the training starts again to train multipliers all over this 10 Southeast Asia countries, and in this case based by using digitalized equipment.